Oh, okay, let's do it. Today we are learning how to do word problems using PERT. You say, what is PERT? Well, let me show you. Okay, PERT is a formula that looks like this. And A equals P times E. Remember, E is that number, 2.718, raised to the RT power, RT. So I call it PERT because it's P-E-R-T, PERT. Now, in your book, they have the letter K instead of T, but it's the same formula. K takes the same place as R, so it's just not a word like PERT. Okay, so anyway, this is the formula we are going to use today to solve this problem. So when we have a word problem, A stands for the answer, right? P stands for your starting value, your starting population. R stands for the rate. K and R are the same. They stand for the rate, right? And then T stands for time. Now, sometimes time is in years, sometimes time is in minutes. It just depends, right? So the P is the starting population, right? Starting population, initial population, initial population. We'll use pop. There we go, initial population. Well, what are we talking about? We're talking about the population of grizzly bears. Grizzly bears in a national park, right? So here we go. 5 years ago, the grizzly bear population in a national park was 325, right? Today, it's 450. So what do we supposed to do? We're supposed to find the annual rate of growth. How quickly do the bears grow, right? So I have to have a starting amount of bears. That's 325 bears times E raised to the, right, raised to the KT power. That's what we're trying to do, right? Well, we know what time is. Time is 5. 5. So we're going to put 5 right here. So let's get rid of T and put 5. K times 5, or R times 5 if you want to say R. And that equals, the answer was today there's 450, right? I started with 325. And now there's 450 bears, right? So can I find K? Yes, I can. This is a problem just like what we did yesterday. You have to solve for, you have to get K by itself, right? So that means you have to get E by itself. So what's holding the 325 to the E is multiply. So I'm going to divide by 325. So 450. Where to get 750? Divided by 325. 325. Okay, so that makes this go away. This is gone, gone, gone. And I have E to the K5. How about 5K? E to the 5K power. 5 times K is the same thing as K times 5 equals, and then I just divide. So what is 450 divided by 325? It's 1.3846. Remember, you have to leave it 4 decimal places. We need the 10,000th place, 4 decimal places. Now then, how do I solve questions like this? Well, I have to take the natural log of both numbers, right? The natural log of both things. And the cool thing is, remember, the cool thing is that natural log and e, they cancel out. So what's left over here is the natural log of that number equals 5k, right? This equals 5k. Go. So what is the natural log of that number? The natural log of 1.3846. Right, all I'm doing is typing it in here. Natural log of 1.3846. You can see that, right? What is that? That's 0.3254. So I have right here, I'm going to say 0.3254 equals 5k. Now, if I divide by 5, divide by 5, then k equals whatever number that comes out to be, divided by 5 is, here we go, k equals 0.0651. So that's what k is, right? Now then, they say, what is the rate of growth? This is k. That's what you're looking for. K is the growth rate. We did it. That's the answer to part A. Find k. Now, what's the other question want to know? It says, whoops, we need to clean out all that junk. So no, we don't want to clear everything. We need to clean out this junk and all of this stuff because it's in the way of my sentence. There we go. Whoops, one more thing. Now, okay. How many years? Now we're looking for time. Here we were looking for k. What's the growth rate? That was find k. K equals, and we had it written down there, 0.0651. And then how many years will it take to reach the maximum population? What is the maximum population? It says right here in the second sentence, the park can support 750 grizzly bears. So how long is it going to take to reach the maximum rate? That's what we want to know. How long is it going to take to reach that maximum rate? So I need to write my equation. Now, I know that I want 750 bears, right? And then I need to know, where am I starting? So if you think I'm starting at 450, that's totally fine. We're going to start at 450 because that's today, right? You have to start at 450 to figure out how many more years do you have to wait until there's 750 bears, right? E to the kt power, except we know what k is. It's 0.0651. And then t is the thing we're looking for. We have no idea the time. That's what we want to know. How long is it going to take? So how do I solve it? The same way we did this other one, right? The first step is you have to get e by itself. So I have to divide by 450. So I'm going to divide both sides by 450. And what plops out? Well, this is gone. And 750 on my calculator, 750 divided by 450 turns out to be 1.6667, right? So what is that? That's 4/3. If you wanted a fraction, you could have 4/3, but we don't need a fraction. E to the 0.0651t. Now remember, the whole idea is to take the natural log of both sides. So I'm going to take the natural log of this one and the natural log of this one. And the reason we do that is because these cancel out. Yeah, baby. And that means that this equals that, right? This whole thing right here, this equals that. So what is the natural log of 1.667? I think I can figure that out. 1.6667. And then that natural log turns out to be, this is, whoops, what happened to my, there we go. This is 0.5108. Check it yourself. Put in 1.66667 and see if you get that number. Equals, and then 0.0651t. So how do I get rid of, I want t by itself, I have to divide by this whole number, right? So I'm going to divide by 0.065. And then over here, I have to do the same thing, 0.0651. Right? So what is that? Let's try it. Divided by 0.0651. Ta-da. Equals, wait for it, how many years, right? Because we're looking for how many years. It was measuring in years. So how many years did it take? What did you get? Did you get the same answer I got? Let's see. Did you get 7.8 years? That's what I got, 7.8 years. So what is that? 7 years and 9 months, or 7 years and 9.5 months, something like that. So we're expecting there to be a bunch of bears in this national park in 7 years, 7.8 years. 7 years and what, 9 months, 9 or 10 months. That's how we do it. So this is part 1. Join me in a second for part 2.